Testing, testing. There we go. Okay. So then checking where we were on Friday, we had gotten to, let's see.
Part to like 6 on Friday.
Yeah.
My heart's in turmoil.
We got into 3.33153. Woohoo! We had gotten there, we just hadn't gotten all the way. So how would you keep going all the way? Okay, let's just go to the next one and make sure that we remember how to do this, although some of you guys might have already. How do I get to the next approximation, or how do I move a delta x away from the previous?
Take the answer you get.
The answer I get, which is the y value, right?
Plus the x value plus the same y value times the interval.
But why are we doing the x value plus the y value?
Because it's yx whatever that.
Good, we're plugging into the differential equation the previous point, which would be the previous x with the previous y, 3.33153, all times h, which would be the step. And then we have to go ahead and plug in and solve. Right? So we go ahead and plug in and solve. We'd have to actually add the x with the y, which would end up being 3.83153 times 0.1, and we keep going. Okay? At the very end, you should get, well, here's the struggle. Please realize that when you get y1, that is an approximate for f of 1. So your y1 value, even though it is in our table up here, oh, never mind, we didn't actually do the notation. We're saying the y1 is the f. That's pretty much what I show over there at the same time. So we can just say the f of 1, which is our y1, is approximately 5.7812. What do I have? 2.73803. Now, I did want to go ahead and show you guys the table that Noah and Jason are using up here at the front to do the exact same process that we are. But first, really quickly, questions on the general idea of Euler's method. Gabby, go ahead.
When we have the final answer given,
Corey and Brendan, let's go ahead and focus and shush.
Are they going to specify on the AP where to stop estimating?
Yeah. In the beginning of our notes for this section, which was, I think, 7.1b, I talked about what you need to be given. You need to be given some sort of starting point, some starting x and some starting y, a point of tangency, an original point. And then you need to be given some sort of differential equation, which they could say as little f prime, or they could also say as capital f of xy. I guess they could also call it like capital D for differential equation. Anyway, they have to give you some sort of differential equation that will help you with the slopes, and then they have to give you some sort of clue about step size, but they will also need to somehow show or explain or state when to stop, which usually they won't say like how many steps to do. Like this one, I think I said n equals 10, so you had to do it 10 different times. They don't usually put it like that. They usually say, here's a beginning point, approximate f of 1 using h equals 0.1 or 0.5 or 0.2. So they usually tell you like that final one that they want, whether it's f of 1, whether it's f of 10, whether it's f of 2.5. They usually tell you what to approximate. Now, the table method. I have a blank. Oh, no, I don't. I guess I erased it. There we go. Okay, in your book, if you guys look at this really quickly, I think this is roughly where Jason got his table. This is a different example than we were doing in class on Friday, but I think you guys should be able to pull out pretty quickly the information from the table. This is how the book models for us to do Euler's method. Noah and Jason are finding it quite helpful, and it is allowing them to keep track of everything that's going on the entire time. You do have to set up the table itself. However, can you guys just tell me, what are some of the givens that were... Well, tell me all the givens. What's something that was given to you as to how they started making this table in the original one?
A point.
Right, the initial point.
So dy dx is equal to x.
So x of 2 is equal to 0. They also gave you that...
dy dx is equal to x plus 4.
Yeah, they might have said it dy dx. In the notation of the last example, it would have been f of xy. They also told you that delta x, which is the same thing as h, just kind of doing some synonyms at the same time, would be what? 0.2, right? And what am I supposed to be approximating?
Point.
What point? No, but what point am I finally trying to approximate? What am I trying to get up to?
2.8. 3.
Here it gets a little weird. Approximate f of 3. Now here's what's going to be a little bit weird from the other one that we did, because we would say this one, but that's not the end, this is the end. Okay? Now, here's what you're doing. In the table, if you do choose that you like it and you want to use it, they're saying, let's take the initial point. Let's go ahead and plug that initial point into the derivative. Let's take our delta x, which is the h that they gave us. Let's go ahead and find the delta y by multiplying the slope by the delta x. And this is an approximate for delta y. I don't know that notation, but that's okay. You end up with 0.4. And then you go ahead and you go to the original point and say, okay, the x has changed by 0.2, the y has changed by 0.4. So you do get to the 0.4, but you have an approximate kind of written out in a nice form. Then you go ahead and take this point, and it's like, okay, cool. Now I'm finding the new slope, still taking the same delta h. I'm multiplying the two together, and I'm adding that to the original y. Now, is it technically the same math that we were doing? Yes. Because you are, every time, you are stepping up in your x's. You are using a previous point to get to the next point, which is what we're doing. We just show it backwards. We kind of show like, hey, f of 2.4, let's go ahead and go back and plug it all in, and we'll get the 0.92. So both ways are right. Let me just show you once again how to compare this with how I would show doing it. I would say, okay, y of, you can also use f of if you want, y of 2 is equal to 0. What would I show next?
Y of 2 plus 0 plus
F of
2, 0.
times, what's my delta? Now, pause. What's something that's a grave mistake and a grave error?
Equals.
Now, what should it be? Good. It looks like a congruent symbol. It means approximate. Then I can go ahead and say 0 plus, and I would plug in 2 plus 0 is 2. 2 times 0.2 would be 0.4, and I have 0.4. So I also get to 2.2 and 0.4, just not using the table. I'm using basically a rearrangement of a tangent line, realizing that Euler's method is ultimately an accumulation of tangent lines. Maybe not accumulation, adjoining forces. Let's just do one more and make sure we got it. How would I have found 2.4?
Just gotta plug it in.
Take the previous point. I would have gone ahead and done 0.4 plus, add the two together, 2.6 times 0.2, or cut into 5. Would have ended up being, what was it, 0.52? Which ends up being 0.5. So guys, both ways are fine. You still do the same math. You still kind of show the same notation in the sense that you have to write I write the point in my differential equation, then I plug in by adding and multiplying. They have to multiply when they go here, and then they have to add the same way I have to go ahead and add to the original. So the same math is going on, but if you like one organization rather than another, you're okay as long as this one naturally would end up at y of 3 is approximately, at the end of the day, 3.46496. You would end up here naturally. This one, you would have to state from this, f of 3 is approximately 3.46496. So the table, you need to actually state that, whereas this one you'll naturally get. Sound good? Both ways are fine, both ways are appropriate.
Yeah.
But if you do like the organization of the table, just make sure that you make this final statement. With that, let's go ahead and quickly check our evens of section 7.1. Because today is not chapel day, so let's go ahead and get them checked. That way tomorrow we can just bust into section 7.2.
Misty, how do you dry your hair? Do you use like a hair dryer? Do you use towel dry? Do you just let it air dry?
If it's not straight, I probably haven't dried it. I just threw them in. If it's in a French braid, it went in wet. And then if it's straight, yeah, then I probably dried it and then straightened it. That happens around that.
I get you.
Takes time. Alright, cool kids. Oh wait, that's not right. Sorry, here you go.
Oh, I had a question. Oh wait, I guess I'll.
Let's pause. Let's create evens very quickly. I'm going to stay on the screen as long as it takes me to read the answer, and that's about it. Number 8, e to the sine t plus c.
Oh my god, you know, I'm slow panda.
What? What happened?
Why was my answer negative?
Why? Oh, your constant's off?
I didn't do plus C.
The red pandas.
Wait, I got -1 for C.
Oh yeah, you're right.
What is number 28? Wait, how would you get it?
Number 10. Sine to the 4th, u plus c. Don't get tricked by the trick notation.
Yeah, I don't know how to put -1. I'm just gonna.
We'll come back to questions in a second. You're just reading. Hold on.
Can someone ask for number 18?
Pause! Grade. You guys are ridiculous. This is 1 over 10. Okay, CalcBC got a big old lecture today about their discipline and about their motivation and about all sorts of things. Don't make me give you the same one. You know the lecture. You've heard it before.
28.
Yeah. I'm assuming 28 is D because.
Oh, good. What do you guys think it is, D?
D.
Okay.
Well, it's the only one because the odds are D and E.
He has a point.
There you go.
36.
Oh, yes.
Nice.
What do you guys think? Times New Roman? Looks like times, right? There you go. You got 34?
What? Wait, can you go back to 34? I did not get that at all.
No little baby tangents? What happened? Maybe I went to the wrong one. Number 36, E. Number 38, D. Number 36, E. Number 38, D. Number 40, F.
Okay.
Number 42,
42. F.
F.
We have to do like 34, 46.
44, E.
40.
46, A. Alright, Euler's method. Let me give you a second.
I got it right.
46 A.
So happy.
What's 38, 40?
Thanks, Lucy.
So copy, incredible. I did it. I was so close to
Oh, sweet.
Oh, I have a question.
Careful, on number 56, don't write it like that, right? How should you write it?
Y is approximate.
Y of what?
1.7.
Good. Y of 1.7 is approximately negative 0.271. They are saying the Y is in the tangent line. But say Y of or F of, that might be a better way of putting it, F of 0.7 is approximately negative 0.271. 60A is graph B. And letter B just gives basically the reason why. They're saying, they just went through and found the clues. So x being negative will make a positive slope, so that would be in the quadrants 2 and 3. When x is 0, it should be a 0 slope. And when x is positive, it should have a negative slope. 72 is E, 74 is A, and 78, ooh, that was a party.
Oh, I like 78.
Wait, I need to check.
There you go. Long story short.
All right.
Alright, what questions do we have when you go back to the beginning? We've done, wait, hold on, a couple more, still checking.
The volunteer.
You're volunteering.
I have a question.
I need questions.
I'm volunteering.
Wait, you have a question? What's your question?
Volunteers, hands down.
Questions? Hands up. Alan.
I have a question on the answer of 18. Like, if we put the t in absolute value, would that be considered wrong? Like the ln of t, if we made that an absolute value, would that be considered wrong?
Well, they say that. Can we just like do it?
Technically not. That would have been okay, but what? Kyle. I'm looking at you. Kyle. Sorry. Kyle and then Corey talked, and then I was still thinking, never mind. Thank you. As Kyle was saying, and then I was trying to call down Corey, it just didn't work. As Kyle was saying, Alan, because t is greater than 0, he didn't need the absolute value, so as long as you can make it match. But I just make it a little bit for yourself. But yeah, that's okay. So now the question 18, John.
23.
23? Alright, see a few hands. Let me go see who had fewer. Any other questions besides 23 though?
Can I say the answer to 23 first?
It's on.
I don't have a book, Kyle, so can you stop being a little smart butt?
Like this person has.
All these people want number 23? Yes. Okay, Gabby, you have the fewest. Go.
Thank you. Wait, can I just check what grade, if I got it right?
If Gabby doesn't want it, it's Ellen.
Wait, no, I just had another question.
Oh, wait, I have another question.
Okay.
I had a question on 18. I don't know how to do it.
I did 18 first.
And I also have a question on number 78 also. 18 and 78.
I did 18 on the
What's your other question?
56. I do 71. I do 78. I can do any of
See,
those.
I did no work for it. No, I mean, I got it right, but I did no work for it. I just used logic. I did it in my head, I'm assuming.
So you can't explain the logic?
I didn't copy because I didn't know that. I just, because you plug it in. 'Cause you have to, so, yeah, no, I'm not doing 25. You're going to go with hot
I have Corey, we're not going to pick. Yes, I am. You're more than me. It's unfair.
I have the least amount, I think.
No, Kyle's raising his hand too. Kyle's.
Oh, wait, is that 50?
Jason, 56.
I think 18.
Go raise up.
Can I do 56?
Jason.
Or whatever that number is, that after. 56, right?
Gabby, go raise 56.
Can I do 56?
Jason, go raise 18.
Oh, you can go first.
I can do 78. I can do 78. Raise both of us.
Raise
What
both.
are you doing?
18.
Okay, 23 and 78. I see. Alan, what do you want?
78.
Yeah, go take it. And 23.
Who's Katrina?
Technically, out of all the ones whose hands are raised, Lucy, you win it.
This is unfair.
Lucy,
I was right from the beginning.
now Lucy and Katrina and Kyle all have 4 and they're tied.
How
many does Kyle? Who has the highest?
I have at least.
I'll go look.
But it was one more every time there's four, I shoot.
You can raise that.
Alright,
Alright, those begin reading. Section 7.2.
Thank you.
I'm not.
Okay, next time there are questions. Listen carefully. Next time there are questions. Anyone with 0, I'm calling you to try it.
I have 0 and I think I'm like 10 point something.
I have a 0 in my heart.
That's kind of sad.
So why are you like something similar to what's the description?
You guys get a great example of some of your questions.
What?
One question.
Or little calendars in the back.
Well, yes.
Do you guys see pattern recognition?
I was like, I was going through the space that wasn't scary. And then there was this monster next to me, and I wasn't scared, and I wanted to see if I could get them to break character. So I turned and I yelled at them. I was like, "You can't scare me! I look in the mirror every day." And they went, and they went.
axes.
I got them to locate right there. And that was my goal. Oh my god, it was so funny. But for the most part, I was terrified.
Yeah, I would have been.
Misty, so is you sub after this, or?
There's no yourself.
Yeah, what are we gonna do?
Wait, we are doing USEP claim. I thought we were doing aggregation by parts.
Oh, yeah.
That's okay. The USEP still gets hard. This is USEP.
Oh, okay.
Correct. Back where we do.
It was
Cute.
How is this?
Oh, just like copy from it?
Because the odds are incorrectly used or not even done except maybe even right.
Yeah, exactly.
No, I'm saying she squealed like a pig.
I'm trying to do
See, I don't know. Yeah.
Jason.
Johnson. Junior.
No one leave.
Yeah, I
Brendan or Paulson?
It's actually great.
The work looks good for everything else.
Just this one is like.
And then he said popcorn now.
My name's my name. I can't change it.
How many of you guys coming out to support your Heritage Cross Country team?
We're coming. See, we're bringing the Black Hole to cross country. Yeah. I'm gonna see if I can get some cheerleaders to come after we're gonna do their trip. And the cheerleaders are there, right?
The only part about the race that matters is the last quarter mile.
Which is how makes them that happen.
Yeah, when is that?
The race is
Alright, as the couple there so finished. How do you find derivatives? Well, you guys just fill in the rule. What would be the rule of f of g of x?
Chain rule.
Yeah, which would be?
F of u times u prime. F prime of g of x times g prime of x.
We're going backwards, right? Hey, what would be the derivative of f of g of h?
F prime of g of h of x times g prime of h of x times h prime of x. Can I give me points?
No.
I'm participating.
Go home, Corey.
I want to.
So, question.
You guys want to be?
Thanks, guys.
I don't want to be for
I'll put
calculus.
myself confident.
I think I only want to be for calculus. And did you?
How do you go backwards then? What if you have an f prime of g of x times g prime? If it's perfectly there, technically couldn't I just go back to an f of g of x?
Yeah.
Wouldn't I have to see that it's perfectly there? Don't kill me. And what would be the answer to the second integral?
That one plus
F of G of H and
But the dilemma is you have to spot it. Now, how does U sub work? Just a quick reminder. Couldn't I say that U is equal to G of X? Du is equal to G prime of X dx. And then couldn't I rewrite this to be F prime of U du? Which would equal F of U plus C, which would equal, when I plug in U as G of X, F of G of X plus C? Which one's easier to look at, F prime of G of X times G prime and figure out all that, or just F prime of U and anti-derive F prime? Exactly. Now, for some of you, the mental math, you can do the first. But for a lot of you, it's going to simplify if you do U sub as to what you're looking at to actually anti-derive, and you're making sure that you're dealing with the U prime to do appropriately. Now, what's going to be a little different when we go to the bottom one?
You have to do U and B. It's like, you only use two, but that requires two U's. What you gonna do?
We're going to have to use U. We're going to have a du. But hold on, how am I going to get that totally substituted? So instead, you probably won't realize the U is everything it is. Probably you'll just realize that U is H of X.
du h prime of x. But does that take care of everybody?
No.
So then we have to think about, well, there must be another one. So you could say v. So then we could go ahead and substitute and have the integral of f prime of v times, ultimately, dv. Because this would be your g prime of u, du, and then you would plug in your d, well, you would substitute your h prime of dx to be du, and then you have your g prime of u du, substitute to be dv, and then you have your f prime of v. So it does ultimately end up substituting to help us, where we can say, hey, the integral is f of v, and v is g of h of u, which is g of h of x. But what? The integral of f prime of v would be f of v, and f of v would be f of g of u, and f of g of u would be f of g of h.
So you want to u?
U is always the innermost, right? So I chose u to be h. And then when you find du, then you use h prime dx, which deals with that. So the match does du, but then I have g prime of u du, and now I need to make that into my v. In order to go ahead and keep on going. That one doesn't match. This one doesn't match. It just depends on where you're going. Alright guys, here's the idea.
I am really confused.
Here's the idea. You've seen U sub before, so we're going to see how well we do with mental math with U sub. Then we're going to expand to those that aren't exactly mental math ones, for most of us. But first, we do have problems all around the board. We're going to quickly go back and mark down their points. If you guys need pictures, you can grab pictures. You can ask me outside of class. If you don't see your question right away, if you need to check over it again tonight, and let me know if you understand or not. But does anybody see anything right now that they would like further explained? A few of these, like it was one or two of you that had a question on it. Okay. Feel free to come and ask me later, and I will, if you can, take a picture of their work first, though, so that I can help you double check as to whether or not they went right or wrong. So we're marking down Gabby's point, Alan's point, Lucy's point. Wasn't there one more?
Corey.
Jason. Okay. Really quickly, everybody's here today except for Emily and is that it?
I was like, what is that pointing to?
I think so.
Alright, kiddos, ready for mental math?
Yes.
I don't have.
Yeah, not very.
Want to take a picture of it?
Oh, y'all, that's such a smart student. Maybe sometimes I forget.
It's probably a good thing, Ken.
Alright, ready, set, let's see what we can do. Go! You can try to mental math it, or you can try to basic U sub it. U, make it the inside. Ooh. Huh? The first one, maybe you could do without U sub. You could also do it with U sub.
Oh, yeah. Wait.
Wait, is there like a noise? Do you hear like a breathing noise? Oh.
The first one, you can do it with U sub, or you can do it without U sub. Some people might want to make. Yeah, the first one you don't have to do U sub. You could distribute. This one's a little harder to see.
Let's see.
If you can, mental math is cool. If you want to write out U sub on letter A, the U I was indicating, or I was trying for, was x squared plus 4, but you could also distribute and use the power rule.
For those of you watching the video, I am gonna freeze the screen so they can't see the answers so that they keep working.
I'm done. You guys got it?
What? With all of them? Did you just mental math them right now? False. Are you guys just switch from mental math?
I did look at it for about 15 seconds before I went over.
The whole.
Are you sure this is 15?
No.
Wait, that'd be like 5 seconds per call. What?
I'm not unveiling it yet. I want to, but I'm not.
Do it. I don't understand.
I didn't show work. Like, I did mental math, and we're not all there, and that's not necessarily a bad thing, because what's bad with mental math sometimes?
You make mistakes.
Everybody makes mistakes.
Except me.
True. But when you try to do shortcuts,
It doesn't work.
it doesn't always work. Sometimes it does, and then it gives you sometimes false confidence. It always works.
But you don't have to do yourself for the dollar. You can just do it. I'm a liar.
I mean, you can foil it out, but the problem is you still have to do so. I would make you x cubed minus 1.
Yeah, I know. I know. Mixed square. They're cancel.
Do the negative 2.
Yeah. So 1/3 x cubed minus 1.
Oh, yeah, that makes sense. That makes sense.
Add 1.
1/3 x cubed minus 1. Oh.
The negative 1.
It's negative 1.
There you go.
Negative x cubed minus 1. So it's negative 1 over x cubed minus 1.
You guys ready?
Almost.
Now pause. You did not need to go as fast as others, number 1. Number 2, you did not need to do this mental math-wise. I will show a little bit of work, just in case you did show the use of, and that is okay. But since we've seen it before, there was the possibility that some of us could have done mental math because in letter A, quiet, letter A, if you chose x squared plus 4 as your u, what would be your u prime? Or your dx?
X squared plus 4 du is 2x.
2x, and it would, when you solve for dx, cancel. Letter B, if you set u equal, you guys tell me, u is
X cubed minus 1.
x cubed minus 1, not the square. Du is 3x squared, which would cancel when I solve for dx. Now, C, u is, because du is secant squared of x dx, which will cancel. So at the end of the day, do you guys agree?
Yes.
Yeah. I know it's.
Yes.
Wait, what?
This one could have been seen as u to the 1 du, which would be 1/2 u squared plus c.
Shouldn't it be 2/3 x cubed?
This one could have, nope, add 1. So 1 plus 1 is 2, and then 1/2.
But when you just makes 2x squared plus
Oh,
8x.
if you foiled it out, I didn't foil it out.
Oh, if one I would make it.
I kept it u to the 1 du. It is an x cubed, but then add 1 would be x to the 4th, which is what mine's going to have.
I mean,
Oh, power
I
1.
figure out what it is.
This one would be du over u squared, or another way of looking at it is u to the negative 2 du, which would be negative 1 u to the negative 1 plus c. Careful, add 1, not subtract.
I know like I cancel out, but
Oh, remember you can make
These are doable.
you could plug that in, and so then the 3x squared is canceled, the du replaces, and make that u. If you guys want to see the u sub actually worked out, you just haven't technically reviewed it yet. But yeah, that works. Once again, Noah just said it perfectly.
Yeah, no one.
We can do U sub in our heads maybe for some of these because the U sub is perfect. When the U sub starts being imperfect, that's when we start getting in trouble. And last but not least, this would end up being u to the 4th du, because u is tangent of x dx, du is secant squared of x dx. When you go to plug in and divide, they cancel out. Now guys, we will definitely be doing some by hand. So this was not meant to make you feel maybe rusty, but not unable, not incapable, just seeing if we could do maybe some mental math with u sub when the du's or the u primes match perfectly. But even when they match perfectly, did some of you guys make mistakes? Yeah. That's okay, but you can practice u sub.
Yeah.
And nothing else, it'd be nice for all of us to be able to do more mental math with u sub, right? But carefully such that we're not killing little woodland creatures. Okay. So.
Yes.
I'm going to try mental mathing it. For just a couple of you, you might want to try mental mathing this one, but for most of us, let's just say, who's you? Who's du? Let's plug and check.
Okay.
Is this?
Oh, you have to solve the.
Does anybody want to make a mental math guess?
It's 5/3 times.
What is it, 5/3?
2 square root of u. Square root of 3x plus 1 plus 6.
Okay, we'll see if he's right. 10/3. Square root of 3x plus 1 plus c. That's what I got. Well, let's see if we're right. What's u equal? What's du equal?
3.
Which we take that and say dx is equal to, right? Okay, now the goal is to plug in. We need to pull that 5 out, right? He's not really helping anything. Can I also put in the du and pull out the 1/3? Is that okay?
Oh, it's good.
So I'm plugging in the du. I can pull out the 1/3, it's just a constant. The 5 isn't helping anybody. And can't I make this u to the negative 1/2?
Yep.
Is that okay?
Oh my gosh, no.
Yeah, you're following it?
Well,
Yeah.
I did 1 over square root of u, then and then you probably just did it along the column.
So 5/3 u, negative 1/2 plus 1, times the reciprocal. Did you get it?
Yeah.
Final answer, 10/3. Dun, 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 dun. Questions?
I was like, I could have questions until I took out class.
Okay, good. Oh wait, but we're following, we're tracking?
Yeah.
Pause, do you have to be first?
Yeah.
I want to be right. Yes.
Yeah.
Right's better than first.
You have to be right and first.
Right and first? Okay. You do you. You do you. Ready, set, go. If you need to take it slow and steady, take it slow and steady. It wins the race sometimes. At the end of this.
Tell that to the track.
Yeah, to the fourth problem. Ooh, and it's a definite interval.
You have to do this in your head.
Can't you just plug in everything then?
Wait, you can't just plug in right now. You have to anti-drive.
No, I know one negative 1, but I don't want to do it by
Okay. Or mental math with u sub integration, but not with numbers.
No.
Oh, no, no.
Oh.
That's
There's the
2/3, 1/5, right?
glass simplified.
How's it one of those?
I forgot all
Katrina remembers this.
Felix Mitchell. No. Did you? No one. What did you get? That's one. I'm not so mad at this. Oh, but I forgot about
You don't need a plus C because we have the thing.
Don't kill a panda the other way either. Pause! Anybody got there?
I haven't gotten anywhere.
It's 2/3.
Don't worry. U equals, lock it with steps. Plus. Because you can do the mental math, if you cannot explain it, how much does it really work?
nothing.
Okay, here we go. U equals.
3x plus 1.
Yeah.
Dx squared. Solve for dx. Plug in. X squares cancel. Gives you 2/3. Pull out the 2/3. Integrate the u to the 5th. Or u to the 4th. One-fifth u to the 5th. One-fifth u to the 5th.
You don't have to use U-bounds, you could go back to X's, but if you were using U-bounds, because sometimes the AP forces it, 4 cubed is 64 plus 1 is 65. Negative 1 cubed is negative 1 plus 1 is 0.
Nice. Actually, wouldn't U-bounds have been easier just because then you plug in 65?
Thanks, Carbon.
Probably. It would require less writing, because then otherwise you would have had to go back to the X's, then plug in the 4 and the negative 1.
Wait, it's not 65, it's 60. Oh, wait,
Plus
one.
Plus 1.
Silly.
Pause. It's okay. Take your time. Questions? Okay. Once again, it's not about getting it first. So if you need to take a little more time on these examples tonight, no stress. No stress.
Oh no, it's 65.
Oh, yes.
So, do I need to write notes on U-bounds?
No.
I don't think so. Let me just go ahead and highlight. If you are plugging in bounds, or if the AP plugs in bounds with DU, they must be U-bounds, not X-bounds. Please be careful. But if you're allowed to solve it on your own, you can substitute back to X's and then use the original 4 and negative 1, but please do not get them confused. Can't use X-bounds with U's, can't use U-bounds with X's. Yeah. I mean, AP sometimes forces you. Sometimes forces you. So the next page was just taking notes on U-bounds, which I think you guys are mostly okay with. So I'm just showing you in the way that I solved it using U-bounds. Okay? Now, I don't think our goal was to finish this entirely today. Hopefully we're going to keep working on it a little bit. But guys, are there some rules we can think of with U-sum? Yes, there definitely are. Like ln of U, A to the U is one we get commonly confused. Log base A of U are ones that we don't like as much. We have our inverse trig integrals, which we can use with U's, but we're going to have some fun ones tomorrow. So get ready to have some fun. If I were you guys, I would start working on homework to get some of the basic ones out of the way and see where do you get stuff.
This is you're so clever.
I know which bounds to use for the very last one you use.
The bounds?
The one you use.
I mean, if you know you're not going to see him the next day, that'll just be really awkward and then he'll
Alright guys, get the basics down tonight so that tomorrow we can work on the tricky ones.
Really? It's only one thing.